Hi, this lesson is about antiderivatives. So the prefix anti means not or the opposite of the derivative. So we're going to let capital F represent the antiderivative of little f. And so if capital F is the antiderivative of little f, then f prime, capital F prime of x must equal f of x. So the process of finding the antiderivative is called antidifferentiation. So the general antiderivative would be represented by capital F of x plus c, where c is called the constant of integration. So we haven't talked about what integration is yet, but this is the introduction to the topic of integration. So it'll make more sense in a little bit why it's called the constant of integration. So to remind you of your derivatives, your derivatives for the trig functions, so that we can actually identify the antiderivative, we have this table here. So if your function little f of x is sine of x, the antiderivative capital F of x is negative cosine of x plus c. And so that is because if I let f of x equal negative cosine of x plus c, as I just stated there, so then capital F prime of x, well, what's the derivative of negative cosine of x? Well, that's just sine of x, and the derivative of a constant is c, so that's where that comes from. And the same is true for everything in this table. So the antiderivative of cosine of x is sine of x plus c. The antiderivative of cosine of x cotangent of x is negative cosecant of x plus c. Antiderivative of secant of x tan of x is secant of x plus c. The antiderivative of secant squared of x is tangent of x plus c. And the antiderivative of cosecant squared of x is negative cotangent of x plus c. So if we're talking about expressions with powers, we have something called the anti-power rule, which is the opposite of the power rule. So if f of x is equal to x to the n, as long as n is not equal to negative 1, then the antiderivative capital F of x would be 1 over n plus 1 times x to the n plus 1. So notice that the exponent, we are adding 1 to the exponent, and then we're multiplying by the reciprocal of that number. So that will be your technique to find the antiderivative of a variable raised to a power. So here's an example. If you want to know what the antiderivative of x cubed is, well, you add 1 to 3 to give you 4, and then you multiply by the reciprocal of 4, which is 1/4. So the antiderivative of x cubed is 1/4 x to the 4th plus c. Same is true if you have a coefficient in front of the variable. So I'm calling the coefficient k. So if f of x equals k x to the n, well, k just gets multiplied by the antiderivative of x to the n. So you get k over n plus 1 x to the n plus 1. And again, k is just a number. So here's an example. I have 9 x to the 1/2, and the antiderivative would be 9 times 2/3 x to the 3/2. And when you simplify the 9 and the 2/3, you get 6 x to the 3/2 plus c. Again, the 3/2 here comes from adding 1 to 1/2, and then you multiply the expression by the reciprocal of 3/2, which is 2/3, which is why you see 2/3 in front of the variable. Okay. So if you have a rational expression where you have something in the numerator and a single term in the denominator, or you have a product of expressions, then you have to simplify them first before you can apply the anti-power rule. Remember, there is no anti-quotient rule. There is no anti-product rule. So here I have a rational expression, a quotient of two terms on top and a variable expression on the bottom. So when you simplify them, you're basically just dividing these expressions. And then you use the rule for exponents, which is to subtract the exponents. So x over x to the 1/2 becomes x to the 1/2, and 5 over x to the 1/2. Well, we rewrite that so that your variable is in the numerator, and that's 5x to the negative 1/2. Then you apply the anti-power rule to those two terms. And so when you add 1 to a half, you get 3/2 and then multiply by the reciprocal. So the first term is 2/3 x to the 3/2. And then for the second term, we do the same thing. You add 1 to negative a half to get 1/2, and then multiply by the reciprocal, which is 2. 5 times 2 gives you 10, and then don't forget to add your constant. So that's your antiderivative. So in the next example, you have a product of expressions. I have the square root of x times x minus 3. Again, first thing you have to do is distribute across. So you have to add your exponents. Square root of x times x gives me x to the 3/2. And then square root of x times negative 3 is minus 3x to the 1/2. Then we apply anti-power rule to those two terms. So when you add 1 to 3/2, you get 5/2. Multiply by the reciprocal, that's 2/5. Do the same thing to the second term. Add 1 to the 1/2 in x to the 1/2. That gives you 3/2. Multiply by 2/3. This time the 2/3 gets multiplied by 3. So that leaves you with just 2. So your antiderivative is 2/5 x to the 5/2 minus 2 x to the 3/2 plus c. And again, you can always check your antiderivative answer by taking your antiderivative, taking the derivative of it, and seeing if it equals the original function. All right, and then finally, in this section, we're just going to talk about what the antiderivative of e to the x is. Remember, the derivative of e to the x is e to the x. Therefore, the antiderivative is also e to the x. But when you're looking for a general antiderivative, you always add that constant of integration. All right, so we're going to do a few examples. So we want to find the general antiderivative for each of the following. So our first example here is that f of x is equal to 4 square root of x minus 2e to the x plus 5. So the first thing you want to do is rewrite the radical as with an exponent. So that gives us 4x to the 1/2 minus 2e to the x plus 5. Now we're ready to take the antiderivative. So you no longer call it little f, you call it capital F of x. You add 1 to the exponent to get 3/2 multiplied by the reciprocal, which is 2/3. Then we move on to the next term. So we have 2e to the x. Remember, the antiderivative of e to the x is just itself. So this remains the same. And then what's the antiderivative of a constant? Well, remember, it's not a derivative, so it's not 0. The antiderivative just means that you attach the variable to it. So the antiderivative of 5 is 5x because the derivative of 5x is 5. So you should be able to go back and forth easily. And then you add your constant. Okay, so there's just a little bit of work here to simplify. 4 times 2/3 gives you 8/3 minus 2e to the x plus 5x plus c, and that's your final answer. So again, if you took the derivative of this, you would get back to your original little f of x function. All right, so now I have g of t, little g of t equals 8 sine of t minus 3 secant squared of t. So since I'm using different notation, we're going to call our antiderivative capital G of t. So the antiderivative of sine is negative cosine. So I get negative 8 cosine of t. the antiderivative of secant squared is tangent, so I get minus 3 tangent of t plus c. So I did the check here on the right. So the check would be, is the derivative of capital G of t equal to little g of t? Well, the derivative of capital G of t would give me negative 8 times negative sine of t minus 3 secant squared. Okay, but negative 8 and negative sine leaves me with 8 sine of t minus secant squared of t. So that is little g of t. So g prime of capital G prime of t equals little g of t. So you know that. You got the correct answer. So here's another one. This is a product. I have h of x is equal to x squared plus 2 times 3x minus 1. So like I mentioned before, there is no anti-product rule. So first we need individual terms, and we get that by foiling. So when you foil, you get little h of x is 3x cubed minus x squared plus 6x minus 2. Then we're ready to take the antiderivative, so that's when we call it capital H of x. So you add 1 to the exponent and multiply by the reciprocal. So that's why you see the 1/4 x to the 4th, but then don't forget, just multiply by 3. You do the same thing to x squared, add 1, gives you x cubed, multiply by the reciprocal, that gives you 1/3. Same thing with 6x, add 1 to the exponent of x, so that gives you x squared, multiply by the reciprocal, that's a half, and that whole thing gets multiplied by 6. Now remember, the antiderivative of a constant is just attaching the variable to the constant, so that's minus 2x, then plus c. Then we simplify our fractions, or multiply whatever's appropriate. So you get capital H of x equals 3/4 x to the 4th minus 1/3 x cubed plus 3x squared minus 2x plus c as a final answer. So if you were to check this, if you took h prime, capital H prime, to see if it equals the original function, well, it wouldn't exactly equal what we started with. If you were to check it, it would equal the expanded form. All right, so let's move on to a quotient. Again, there is no anti-quotient rule. So what I need to do here is divide each term by 2 root t, which is the same as 2t to the 1/2. So that's what you're seeing here, that each term is separated. So it's still little f of t. In the next line, it's still little f of t. All I did was subtract the exponents in the first 2 terms. And in the last term, I just moved the t up to the numerator and wrote it as t to the negative 1/2. Notice that the 2, that remains in the denominator. That's fine. So it basically creates a coefficient of 1/2 in front of each of the terms. All right, then we're ready to move on to taking the antiderivative, which is right here. So you add 1 to the exponent and then multiply by the reciprocal. So the first one becomes 1/2 times 2/5 to the 5/2. And then the second one becomes 1/2 times 2/3 times t to the 3/2. And the last one becomes 1/2 times 2 times t to the 1/2 plus c. Then all of the fractions here will simplify. So your final answer is capital F of t equals 1/5 t to the 5/2 minus 1/3 t to the 3/2 plus t to the 1/2 plus c. Okay, so we're going to change our notation a little bit. So here's a little note for you to keep in mind. The general derivative of f prime of the derivative is the original function. So plus c, because we're talking about general antiderivative. And that's because the antiderivative is the opposite of the derivative. So if you're given f prime and you take the antiderivative, you get f of x. Okay, so let's just practice taking the antiderivative using this notation. All of the rules will remain the same, just different notation. So for these examples, we want to find the general antiderivative of each of the following. So our first example here is that f prime of x is equal to -3 cosine of x plus cosecant x cotangent. So the antiderivative of f prime is f, little f. So the antiderivative of cosine is sine, that gets multiplied by -3. The antiderivative of positive cosecant cotangent is negative cosecant of x. Then you attach your constant of integration. Again, until you're really confident about these steps, I would take this additional step of taking the derivative of what you just found and seeing if it equals the original function that was given, which was f prime of x. So if you took the derivative of -3 sine of x, well, that's -3 cosine of x. And if you took the derivative of negative cosecant of x, because you end up with a double negative, that becomes plus cosecant x cotangent. So if you didn't memorize your derivatives for trigonometry, you really want to go back and memorize them. This would be a very difficult thing for you to do without having those derivatives in your memory. Okay, so here's another one. You're given that g prime of x is equal to a cube root of x plus b over x squared. So the first thing I'm going to do is rewrite both terms so that my variable is in the numerator and written with an exponent instead of the radical, like in the first term. So that means that g prime of x is a x to the 1/3, and b over x squared becomes b x to the -2. We are ready to take the antiderivative. So that's here, and that's why we call it g of x instead of g prime. So you add 1 to the exponent, so 1 plus 1/3 is 4/3, then multiply by the reciprocal, which is 3/4. And a is a coefficient, so that just comes along with the antiderivative and gets multiplied by it. We do the same thing here, add 1 to -2, which gives you -1. The reciprocal of -1 is still -1, and that gets multiplied by b. So when you go on to the next line, you get 3a over 4 x to the 4/3 minus b over x. So x to the -1 got rewritten in the denominator in this line here. And then don't forget your constant of integration. Okay, so let's go on to to the third, a different example where we're given different information. So here, you're asked to find f of t, given that f double prime of t is sine of t minus t squared. Since you're given the second derivative and you need to find the original function, that means I have to find the antiderivative twice. Okay, so first we start by finding f prime. We find f prime by taking the antiderivative of f double prime. So the antiderivative of sine of t is negative cosine of t. And remember, that's because the derivative of cosine is negative sine. So you have to adjust for that by putting this negative in front. Then the antiderivative of t squared is 1/3 t to the third, and then don't forget your constant. Now we have to take f prime and take the antiderivative of f prime to get f of t. So the antiderivative of cosine of t is negative sine of t. Then the antiderivative of the second term, you use anti-power rule, that'll be minus 1/3 times 1/4 t to the fourth. The antiderivative of c, again, attach the variable, is ct. And then we need to introduce a new constant, so we'll call it d, because it's not the same as c. So your final answer when you multiply the fraction in the second term is that negative sine of t, f of t is equal to negative sine of t minus 1/12 t to the fourth plus ct plus d. So we had to take the antiderivative twice to get this answer. So this next example is similar. There's even more work to do here. You want to find f of x. So I'm here. You want to find f of x given that f triple prime of x is equal to e to the x. So this time you have to take the antiderivative 3 times. So the antiderivative of f triple prime of x is f double prime of x. Remember, the antiderivative of e to the x is just itself with the constant. So it's e to the x plus c. Now you take the antiderivative of f double prime to get f prime, which is right here. So f prime of x is e to the x plus cx plus d. Again, introducing another constant. Now we have to take the antiderivative one more time. So we get the answer right here. F of x is equal to the antiderivative of e to the x, well, that's just e to the x. The antiderivative of cx, remember you have to do anti-power rule. So add 1 to the exponent, that's where x squared comes from, and then multiply by a half. So we get c over 2 x squared. The antiderivative of d, we'll just attach a variable to it, that's dx. Then we introduce a new constant, which we call e. So the answer in the box is the original function, given that f triple prime is e to the x. Okay. These are called initial value problems. So with initial value problems, that will allow you to solve for your constant of integration. So that means that additional information has to be given. So you can solve for the constant in an example like what we see right here. If f prime of x is equal to 10t to the 3 halves and f of 1 equals negative 3, then we're going to find the antiderivative by first finding the general antiderivative, which is what you see here. You add 1 to the exponent of 3 halves, that's where 5 halves comes from. Then you multiply 10 by 2/5, that's where the 4 comes from, and then plus c. Now we have to solve for c. Now we solve for c by using the information that's given. So the information that's given is that f of 1 equals negative 3. In other words, when x is 1, the f of x value is negative 3. So that's what you see here. You plug in 1 into your general antiderivative. We set it equal to negative 3. Then when you simplify that, you solve for c, you get that c is negative 7. So your final answer is 4t to the 5 halves minus 7. Oh, my variable is t. I think I mentioned x before. So this here should say t. All right, so let's move on. So this is a review of a concept that we've talked about before, except we're considering it in a different direction. We have displacement, velocity, and acceleration. So the antiderivative of acceleration is velocity. Remember, the derivative of a velocity is acceleration. Antiderivatives means you're going backwards. The antiderivative of velocity is displacement, which we usually call s of t. All right, so let's use these ideas, these initial value problem ideas, as well as displacement, velocity, and acceleration to do the next few problems. So here's our first example. We want to find f of x given that the initial value is f of 0 equal to 3 and f prime of x is 2 sine of x plus 5x squared plus 1. So the antiderivative of what's given is here below. F of x is negative 2 cosine of x plus 5/3 x cubed plus x, right? The antiderivative of 1 is just x, and then your constant. Then you use the initial value information that's given. F of 0 equals 3. So you plug in 0 for x, and we set it equal to 3 as stated in the initial value. You simplify that. Cosine of 0 is 1, so you get negative 2 plus 0 plus 0 plus c. Solving for c means you add 2 to both sides. You get that c is 5. So your final answer is that f of x is negative 2 cosine of x plus 5/3 x cubed plus x plus 5. And that's an exact antiderivative, not a general antiderivative. Okay, So find the displacement function s of t, given that v of t is equal to 3t squared minus 1, and that's in meters per second, and s of 0 is equal to 1. All right, so s of 0 equal to 1 is our initial value condition. So remember, the antiderivative of velocity is displacement, which is what you see here. So s of t, when you take the antiderivative, that means you add 1 to the exponent, that's where t cubed comes from, multiply by the reciprocal, which is a third, but then don't forget you have this coefficient here. So we end up with what you see in this line here. So we have 3 times a third t cubed minus t plus c. Okay, when you simplify, you get that s of t is t cubed minus t plus c. Now we're ready to use our initial value. So s of 0 equals 1. Plug in 0 for t, set it equal to 1. You get that c is 1. So your displacement function is what you see below in the box. That's t cubed minus t plus 1. Okay, so here's another one. A particle moves in a straight line and has an acceleration by of t equal to 6t plus 4. Its initial velocity is v of 0 equal to negative 6 centimeters per second, and its initial displacement is s of 0 equal to 9 centimeters, and we want to find s of t. So you're given acceleration, you need to find displacement, which means that you need to take the antiderivative twice, and you're given an initial value for velocity, and you're given an initial value for displacement. So we'll be using all of this information to come up with our answer, which is the displacement function. All right, so here's our here's our acceleration function. Take the antiderivative, you get 3t squared plus 4t plus c. Substitute in your initial value, v of 0 equal to negative 6, so you substitute 0 in for t, set it equal to negative 6, you get that c is negative 6, so your velocity function is what you see here below, that v of t equals 3t squared plus 4t minus 6. Now we take the antiderivative of velocity to get your displacement function. So again, you're using anti-power rule, your rule for constant, and then attaching a constant to it, which we're going to call d. So I have t cubed plus 2t squared minus 6t plus d. Plug in the initial value condition that s of 0 equals 9, which means substitute 0 in for t and set it equal to 9. You get that d is equal to 9. So your displacement function is what you see here in the box, is that s of t is t cubed plus 2t squared minus 6t plus 9. Okay, here's another initial value problem. I want to find f of theta given that f double prime of theta is equal to sine of theta and cosine of theta, and you're also given that f of 0 equals 3 and f prime of 0 equals 4. All right, so again, you're given f double prime. You need to find f, so we have to take the antiderivative twice and use both of those conditions. So f prime is what you see here. The antiderivative of sine is negative cosine of theta. The antiderivative of cosine is sine of theta. Then you attach your constant. Then you plug in your condition for the first derivative. So I have f prime of 0 is negative cosine of 0 plus sine of 0 plus c equal to 4. Cosine of 0 is 1, so you have negative 1 plus 0 plus c equals 4. Solve for c, you get c is 5. So your first derivative, or the antiderivative of f double prime, is f prime of theta equals negative cosine of theta plus sine of theta plus 5. All right, so now we have to take the antiderivative of f prime to get f. So the antiderivative of negative cosine is negative sine of theta. The antiderivative of positive sine of theta is minus cosine of theta. The antiderivative of 5 is 5 theta, and then again attach your constant, which we'll call d, since we already used c above. Then you use the condition on the function, which is f of 0 equals 3. We plug in 0 for theta, set the whole equation equal to 3, which is what you see here. And you get negative 0 minus 1 plus 0 plus d equals 3. Solving for d, you get d is equal to 4. So your function is negative sine of theta minus cosine of theta plus 5 theta plus 4. Okay, so now you're ready to try the homework on antiderivatives. Good luck.